Hello everyone. Yesterday we looked at arithmetic sequences. Today we're going to look at geometric sequences. By the end of this video you should be able to understand how to work out the nth term of a geometric sequence and also how to solve exam questions on geometric sequences. So let's look at this first example. How would we find the nth term of the following sequence? 6, 48, 384 and 3072. Well, as you can see here, this time we're not adding, we're multiplying each time. That's the point of a geometric sequence. So let's rewrite our equation. We got 6, 48, 384, and 3072. You can clearly see it's a geometric sequence just because if you did it as an arithmetic sequence, it just wouldn't add up. But what we can do is we can check the common ratio between them. So what we're going to do is let's look at what do we need to times 6 to get 48. 48 divided by 6 is equal to 8. So we times 8. 384 divided by 48 is what? You can use your calculator. Yeah, it's equal to 8. And 372 divided by 384 is also equal to 8. So for each one, we're timesing 8. So the general rule of thumb with an a geometric sequence, a geometric sequence has a common form a times r to the power of n minus 1. This is the form that a geometric sequence holds. A is the first number, and r is the common ratio. And so therefore we can clearly see that the nth term is going to be 6 times 8 to the power of n minus 1. And that is our final solution. Sometimes it looks very easy, like something like this. Here is a sequence. We got 5 root 3, 15, 15 root 3. What is the next term? Well, what is it multiplying by each time? What are we multiplying here? We're timesing by root 3. And also here we're timesing by root 3. And also here we're timesing by root 3. And so therefore, the next term will simply be 15 root 3 times root 3, which is the same as 15 times 3, which is equal to 45. Yeah? And by extension, because we found the common ratio, right? And we know what the first number is. So the nth term is simply going to be 5 times root 3 to the power of n minus 1. This even works in reverse as well. So, find the nth term of the following sequence. 1024, excuse me, 256, 64, 16 and 4. Well, what are we multiplying by each time? So let's rewrite this. 10, 24, 2, 5, 6, 64, 16, 4. Each time we're multiplying by, what's 1024 divided by 256? It's equal to a quarter. So 256 divided by that is going to be a quarter. We're timesing a quarter. 64 divided by 256 is also going to be a quarter. 64 divided by 16, also a quarter. And we're also timesing it by a quarter. Our first number, right, is 1024. This is the first number. And this is our common ratio, this quarter. And so therefore the nth term is going to equal 1024 times a quarter to the power of n minus 1. It doesn't matter what the geometric sequence looks like. It will always follow this form. A times r to the power of n minus 1. We can get a question like this though, where we're gonna have to understand how this works. The third and the fifth terms of a geometric sequence are 5.4 and 1.944 respectively. And we're also told that all the terms are positive. Okay, good. So what is the common ratio going to be? Well, let's put this as a sequence of unknowns. We got A, we got B, we got 5.4, we got C, and we got 1.944. The only logical thing we can do is do 1.944 divided by 5.4, which is equal to 9 over 25. But hold your horses though, because remember what we did here. If we were to get 3.4 and times it by the common ratio, we'd get C, and then C times the common ratio is going to be 1.944. So, all we're going to say is that 9 over 25 is equal to R times R. Doesn't that make sense? Because all we're doing is we're timesing R twice. So therefore 9 over 25 is equal to R squared. R is equal to the square root of 9 over the square root of 25, which is equal to 3 over 5. Yeah? So each time we are multiplying by 3/5. So then what is the first value going to be? Well, let's take a look at this 5.4. 5.4, as you can clearly tell, has been multiplied by R twice. Or in this case, we know that it's 3 over 5. Should probably change that to 3 over 5 as well. So all we're going to do is we need to divide 5.4 by R squared. So what is 5.4 divided by 3 over 5 all squared? 5.4 divided by 3 over 5 all squared is simply going to be equal to 15. And so therefore the common ratio is 3 over 5. So we should probably write that down. Our first term is equal to 15. And so therefore, I'll put this up here in red, the nth term is going to be 15 times 3 over 5 to the power of n minus 1. Thank you guys for watching. I hope that this video made sense. If you guys want to see more videos like this, consider subscribing. If you guys have any individual questions to ask, join my Discord server and I'll help as best as I can. If you guys want some tutoring from me, drop me an email and I can organize a quote and a meeting. Keep on learning, as you have no idea what you're capable of doing.